slide comes up, or if you turn to that page in your handouts, you'll notice biology is at the top. This is a slide I stole from Joe Clapperton. She allows us to borrow these things. Ray Archuleta too. He gave me a whole set. He gave me like 200 slides. Use them for a good educational purpose. It's fine. But I didn't put these together, but we got professional people that use these slides and put these together. But this slide is from Joe Clapperton. She's a rhizosphere ecologist. And she was in Canada, British Columbia, I think. Now she's, where's she at now, Randall?
Montana.
Montana. But she is great on soil health. If you have field days, you get farmers together in meetings, get a hold of her, have her come out. But she gave that slide. You've got the biology at the top. The most far and away important category of soil quality indicators is the biological. They're always at the top, she said. Most, meaning those are the most important indicators to reflect soil health. The physical counts for another, 75% was the number I heard associated with the biological. Because biology affects everything. Physical is about 20, chemical is only about 5% of the difference of soil health improvements that we can put into soil by building soil health. Those dynamic soil properties, only 5% of the difference is going to be with chemical. Yet, how much emphasis do farmers put on putting on the right fertilizer? For many years it's been that way. Okay. Are we up and out? Guess we need to log in.
Should work. I'll move you up.
Okay, because this was not, there you go. We'll go one more. Oh, that's back. One more forward. We finished that one. I want to talk about this one. This was an aerial photo that Ray Archuleta took in Mercer County, Ohio, when he came in 2010 to talk to our farmer group there, Grand Lake St. Mary's watershed. He took this picture out the airplane window. He saw this patch of green out here. Oops. Did I do that or you do that?
No, I didn't do it. Right.
Now if we hit it once more, I've got to go. Okay. It's pointing to a patch of forage and a patch of trees. And he says, productive factory workers. Does that make any sense? What does he mean? I'm pulling your leg. Now come on, you know what he means. What's going on there that's not going on in the rest of that whole area where it's bare? But harvest is just completed in this area. Crops are gone.
Still building soil.
Correct. That's the only place there's any active growing roots right now. Rhizosphere is important. We want active growing roots as much of the year as possible. Right there in that area is the only place. You have productive factory workers, you have roots growing, rhizosphere is in good shape, root exudates, all the substances that come out of the root, feed the microorganisms, are happening. But only right there. The rest of this area around it just went dormant. How many businesses do you know open up their doors and close down after 5 months? And the rest of the year they're not open. They wait till next year, open up again? That's a surefire way of failing as a business. Our farms need to be productive, building soil year round. All you need is a growing root out there. They can do that. One of Dave Grant's favorite things he likes to say, his combine's only good for one thing. It's the most worthless piece of equipment he's got on his farm. His planter. He uses it all the time. You don't just plant corn and beans, all the other commodity crops that he has. He's planting the cover crop. All his buddies, all his workers in the soil, they're building his soil, building rhizosphere soil. I'm going to get to that one.
Jerry's telling us we better speed up. So.
Speed up? Okay, we'll speed up. There's a huge cover of corn stalks on the top of this. There's some things that's happening in the soil, your soil, wherever you have a cover. Right at the base of that residue, there's a whole bunch of animals called shredders. Eat that residue, break it up in little pieces. Then right below that, it gets into this area, aggregation active zone. Where that decomposition happens, gets into smaller pieces, then the bacteria, the protozoa, all the other animals, break it down even smaller. The glues and polysaccharides and everything that comes out of their life goes into the soil, holds the aggregates, builds aggregates. And there you get your layers of aggregates. These are some of the animals that are helping to do this. Arthropods and fungi, millipedes, bacteria. No-till systems are balanced in the way of fungi and bacteria. You got both. If you only have conventional, you're going to be strong in bacteria, but your fungi are going to be very much depleted. Fungi have a lot to add, especially the mycorrhiza fungi. Here's a protozoa, one called a rotifer. Looks like a top, spins around through the soil. These guys live in the water films around soil particles and soil aggregates. And they just swim around in there all their life, is sucking in bacteria and eating it. And you know, a bacteria population that is being consumed by other animals in the soil is, on the other hand, exploding in population. And they're new, healthy organisms that are doing everything full speed ahead. You got a healthy population of microbes when you have a lot of these things happening at the same time. Yes, sir?
Have they noticed much breakdown of organic matter from just using nitrogen fertilizer, like super energizing the stuff that breaks down the carbon?
Ooh, that's a good question. I haven't heard Jill talk about that. That's a better question for Jill Clapperton if you ever see her coming around. Nitrogen does feed the microbes, okay? And this reactions, if they have the food supply they need, you have an answer for that,
Yeah.
Don?
Is the folks over in Iowa have shown that when you apply 300 pounds of nitrogen per acre, you increase the rate of mineralization because
Okay.
you brought that carbon to nitrogen ratio of the soil system
There you go.
to something very narrow. And it speeds up the decomposition. You lose carbon and you lose some nitrogen too because of that. And if it goes on for an extended period of time.
Deplete the soil.
Exactly.
Yes, it will. Thank you. Thanks very much, Don. Did y'all hear that? You have questions? That's a good answer. And that's an important answer. It's a good reason why you don't want to be disturbing your soil. And, you know, take advantage of the organic mineralization process when you get going with roots and rising. Okay, let's go on to the next one. Soil organic matter. Food source for most organisms. This talks about carbon, nitrogen. Don's already talked about carbon, nitrogen. If you have questions, you can get stable organic matter and effective organic matter. Effective is soluble. The stable ones, those are long chain. Those are ones that's really been in the soil a long time. But they both build cation exchange, but the ones that are mineralized, provide you mineralization, are the effective organic. These are the different rhizosphere and all the different ecosystems that are in the soil. Every area of the soil is not the same throughout the profile. You see up at the top, we've got detritosphere, that's your cover, then porosphere, concentrated pores, rhizosphere, the zone around the root, aggregate sphere. Got all this environment that's associated with this aggregate. Drillosphere, right side of the nightcrawler burrow, is a separate, very different type of ecosystem. This rhizosphere deal brings these three factors together, plants, soils, and organisms, to the benefit of your plant. This is what's important. 5,000 to 2,000 times more bacteria in the gram of soil, it says, in the rhizosphere. What's going on? Why is that so?
There's food there.
Correct. The best food an organism can get. It comes out of the plant root. It's prime, the best kind of food that organism can get. That's why there's so many organisms there. You need rhizosphere. The take-home message to that is, as often as you can get it, and as wide and big of an area in the soil that you can get it. These here we've had on the previous slide. We're going to go right through those fast. Detritus, this gives you the benefits of detritus. I want to talk about this right here just a minute. Lowers temperature and evaporation. When we're at home, we like to set our thermostat. If we have a way to control humidity in our house, we'll do that. In the soil, microorganisms need a stable humidity and temperature too, but for them, it's life and death. If it doesn't happen, they die. You don't want them dead, you want them alive. So you got to keep the soil protected. That's what the detritus is doing. It keeps the microorganism population healthy and growing. If we control these factors. Just slow it, show this because of different food web, the sources of food, root exudates. This is a Joe Clapperton slide. She said, never want to forget the root exudates, the most available form for the microbes. Okay. Take the soil away, and these are some idea of the diversity of animals that live in the soil. They all have a function. They all need to be there. If somebody's missing, some function isn't happening. Here's just a little picture of some of the different arthropods. You got a sow bug and tiger beetle in the middle there. This is a shredder. This is a predator. This is a scavenger. These are, of course, rugose harvester ants. This is eats fungus. Okay, both of those. The symphyllin. Both of those are different kinds of symphylins. Columbella. Cycles going on. This above ground diversity. You see what's growing on top, but you always want to remember what's in the soil 10 times more diverse than what you see on the surface. If you have a 10-way blend or a 4-way blend of cover crops, the exudates, we're talking about root exudates, type of animals, microbes that live in the soil. One certain plant gives off one certain type of root exudates, and it's very specific to certain organisms. If you want different organisms, you need a different plant. Now, that's how specialized this is. It matters what plants are grown. So, how cover crops work, I'll let you read that. You got that in your notes. Biotic glue. Glomalin, mycorrhiza fungi. When you have mycorrhizae fungi, it's one of the best mutualistic symbiosis relationship in nature. It's said that 80% of plants enter into symbiosis relationships with mycorrhizae. 80%. This is not just a fluke of nature. The Creator knew what he was doing when he did this. Can bring nutrients, phosphorus for example, that's in the soil not available. Mycorrhizae brings it into the plant in available form. Magic? No. It's just the life process of the mycorrhiza fungi is doing this. Also, there are micronutrients that come in that way. We just found out in recent literature that came through. Mark Scarpini shared it in Ohio. I don't know if he shared it in. I don't know if you saw it, Jerry, but there is another type of nutrient that comes into the plant by the way of mycorrhiza fungi, which we just recently found this out in research. Believe it or not, it's nitrogen. The plant can bring nitrogen. The rhizosphere comes around, not the rhizosphere, but the nitrogen comes into the plant by way of the mycorrhiza fungi in organic form. I don't know if you can assimilate that in your mind, how that's a big benefit. But if these mycorrhizae can bring organic nitrogen into the plant, I thought it was nitrate and ammonium or nitrite the plant could absorb. After that, that's about it. That was your main sources of nitrogen. But here we're finding out these mycorrhizae can bring organic nitrogen directly to the plant. These extend the reach. Yes?
Also organic phosphorus.
Also organic phosphorus too, huh? Organic phosphorus and nitrogen. Thank you, Rafi. All right. This picture will make you dizzy. We're going to show this a little bit. Then we'll move it on. What's going on here? That word VAM was up there. Vesicular arbuscular mycorrhizae. All right. If that relationship between the mycorrhizae and the root is happening, the symbiosis, your roots look different, like in this picture. What's on this root? There's soil particles on this root. There's also organic matter sticking to this root. Glomalin, remember that sticky stuff that I said holds the aggregates? It's holding soil and organic matter to these roots. Those roots can get nutrients a lot quicker when that's happening. Okay? Because of the stuff we've already talked about. And then we got another little telltale sign. Dig a little, learn a lot. You got this white stuff here, these white little hyphae masses. Mycorrhizae is growing there, healthy. You got it going on there. You dig in your soils, if you're finding these mycorrhizae, you got this symbiosis is happening. Your plants are able to take up nutrients multiple ways, not just through the conventional ways by the roots themselves, but in this symbiosis way, the help of the mycorrhizae. That's where you get your shovel. You dig into your fields and find out. Do we have these things happening? If you don't, well, you're absorbing some nutrients the old-fashioned slow way, but you can do it much faster with the help of the animals in the soil. Everybody knows what these guys are. You got the neck worms, which are night crawlers. You have endogeic worms. That's in the next picture here. 70% are anecic, 30% endogeic. But 70% are the ones that go up and down. Their burrows go clear to the surface. Water can come in. Endogeic are the ones that they never reach the surface. The burrows go crossways, but they're all pores. And worms are wonderful creatures because what they excrete out the back end has more microbes in it than what they ate. And that's what they are eating. Does that make sense? Creator knew what he's doing. You know anybody else? What comes out the back has more nutrients in it than what's coming in the front? That's, pardon me for being crude here. I mean, that's a special relationship. This is building our potential to grow crops, okay? Maybe you remember that. That's kind of a gross way to remember something neat, huh? Now watch what happens. What's happening here? I'm making you dizzy again, right? It's going around and around. Earthworms mix soil. Top 6 inches, 10 to 20 years, depending on how many earthworms you have. If you don't have the tillage implement, you can mix soil the top 6 inches, and the aggregates afterwards are better than you were before. No tillage implement can do that. But the earthworms can. It's a good reason to have earthworms. Drillosphere, very special. It tells you, I don't know if you can read this in your handout, this is what they do for us. Distributes the carbon throughout, increase water, we talked about that all day long. Homogenizes the soil. Here's a picture showing where the night crawlers sticking out of the hole. This is canola, this mix of cover crops. You can pick the right mix. They actually encourage the development of more night crawlers, more earthworms. Brassicas are good for that. This guy's kind of neat. Columbella. He's about 1 millimeter to 7 millimeters long in the soil. Okay? He eats fungi. That's what he does. In a square meter, there can be 100,000 of these in the soil. In 1 square meter in healthy soil. Why is that good that they eat fungi? Well, everything gets eaten that's in the soil. Okay? When some gets eaten, more grows. And you got fresh. It's not detrimental. We talked about, I think our friend talked about with cover crop talk. Where is he leaving? Tony? I don't know. Resilience and resistance. We heard those words earlier, didn't we? Having cover crops, taking use of biodiversity, allows these kind of things to happen. It gives you more flexibility and resilience, resistance to disease. Resilience, if you have a drought, the water soaked into 30 inches down because you had macropores going down, you got stored water. If you didn't have that, you're not any resilience there. But when you have that, you do. You're gaining so much by using the principles Mother Nature has used for millennia. We don't need to take the credit for it. We just be smart enough to use what God set up in place to work. The Creator made it work. We can also follow suit. Maybe we'll stop with this one right here. Root architecture is important. You dig your soil, you find out where is the healthy soil in your soil profile. And you plant the cover crop that has roots at that depth because you get rhizosphere effect and that builds the soil there. If you need deep soil improvement, you get deep rooted plants. I want to show you this right here. This right here is a corn root. And this is a corn root. what's going on here? Why is that one so light color, this one's dark? The top one is formed in rhizosphere soil, which means the rhizosphere is, throughout the year, rhizosphere effects. What I just showed you with the mycorrhizae, where the soil was sticking to the roots, soil and organic matter is sticking to that root. Much healthier situation. Also, the thing to notice between this and this is canola, this is corn. Canola has a big taproot, some fibrous feeder roots. This has very much of fibrous, more mass of roots. Which one of those is going to have more rhizosphere effect? In wider and broader part of the profile. Where the roots are is where you got rhizosphere effect. It's not too hard to figure out. So you want to get the right cover crop to do the best you can for the soil problems you have. These are just some of the examples. Pea is shallow, canola, wheat, moderate depth, and alfalfa. Some of those things are really deep. I think we'll stop right there. Appreciate y'all paying close attention. Thank you.